We're going to be talking about inequalities and inequality basics when it comes to solving an inequality. So, what is an inequality? An inequality, it's very similar to an equation, except for an equation you have an equal sign. So you know that the x equals this. But with an inequality, you're actually doing a comparison. So you're talking about something being less than or greater than. So you're not going to find an exact solution. You're going to find a range of solutions. So an inequality is like an equation, but instead of an equal sign, you have comparison values. So when you read inequalities, you read them from left to right. So when I think about less than, I think about on the left side, it's going to open up to the right side. So let me make sure we understand that. So the left side is less than because it's opening up to the right side. It's always going to open up to the value that's greater. So left to right, we have less than on the left, greater than on the right. All right, so then we have less than or equal to. So this is going to be slightly different, but not much different. We still have from left to right, the left is less than the right side. But the fact that it has equal to means whatever value we are setting this comparison to is actually equal to that value as well. And I'll show you some examples further on in this video. So then we have greater than. So with greater than, remember it's always going to open up to the greater value. So if I read it from left to right, the left side is greater than the right side. So it's opening up to the left, so the left is greater than the right side. And then we have greater than or equal to, which again is very similar to what we talked about a second ago with the equal to. We're going to actually equal that value. So let's look at some inequalities and let's talk about what values are included within them. So when I'm looking at this example, I have x is less than, I know it's less than because when I read it left to right, it's opening up towards the 5. So x is less than 5. So if we're talking about less than, we're including all the values that are less than 5, but it does not include 5. So it goes up to 5, but doesn't include 5 itself. So an example of that would be 4, could be 4.5, could be 4.99. I mean, 4.99 is still less than 5, but it's not going to equal 5. It could be negative 100. Anything that's less than 5 is in the solution range. Now, let's kind of skip down to where it says x is less than or equal to 5. So this means that everything is less than 5, but it does include 5 this time. So again, my examples would be very similar. I have 4.5, 4, I could do 4.99, but this time it can actually equal to 5. So that equal to means that it includes 5 in the solution set and the solution range. Or it could be, again, negative 1,000. Anything that's less than 5 will make the inequality true. All right, so then we're going to have greater than. So we have x, because we're reading it from left to right, x is greater than 5. It's opening up towards the x. So that means that anything that's greater than 5 is part of the solution, but it does not include 5. So that could be 5.01. 5.01 is greater than 5. It doesn't equal 5. I could say 10. I could say 1,000. I could say 7. Anything that's greater than 5 is part of the solution region. And likewise, if I have x is greater than or equal to 5, but this time I can actually equal 5 itself. So it still includes everything that's greater than 5, but it includes 5 itself. All right, so let's look at some graphing examples here. So let's look at it on a number line. So in my number line here, first thing we need to kind of look at is if it's less than, anything that's less than, you're going to shade to the left, okay? Anything that is greater than, you're going to shade to the right. Why? Because greater than goes to the positive direction, so that's going to head towards the greater than values. Less than is going to go to the left, which are the lower values. The other thing that we've got to make sure is we've got to indicate whether the value is included or not. So that's going to be important. So if I have greater than or less than, that means that it's not included. So that's going to be an open circle. If I have greater than or less than equal to, that's going to be a closed circle. That means it is included. So when I look at this example right here, this example is less than. I know it's less than because when I read it from left to right, x is less than 5. So that means we're going to shade to the left, but we're going to make sure that we have an open circle. Why is it open? Because it's not equal to. And we're going to shade to the left side of it because it's less than. All right, so in another example here, we have x is greater than -2. So we're going to shade to the right side, but we're going to make sure we have an open circle at -2. Now, I'm not drawing these number lines to scale, and the reason I'm not doing that is because we're trying to fit them in on the page, but you should be able to recognize that since I'm putting 0, that negatives are below the 0 and positives are above the 0. So if we're going greater than, we're going to shade everything to the right. All right, so for the next one, I have greater than or equal to, or excuse me, less than or equal to for this one. So if I read it from left to right, that's going to be less than or equal to. So on my number line, I have -8. And I'm going to do a closed circle this time because it is equal to. And it's less than, so we're going to shade to the left side. All right, so for the fourth one on this page, we have x is going to be greater than or equal to 4. So if I have greater than, that's not going to change anything except for shading to the right. But we have equal to, so it can be equal to 4. So we got to do a closed circle to indicate that. So we have 0, we have 4, and we're going to close circle at 4 and shade to greater than. Now, in just a second, this video is going to pause. I want you to try these inequalities on your own and graph these, and I will give you the answers to check in just a second. All right, so now that you've had a chance to graph these, let's look at the inequalities here. So let's just kind of go ahead and compare. So this one is x is less than. This one is greater than. This one is less than or equal to. And this one is greater than or equal to. All right, so when I'm looking at -6, so less than means we're going to shade to the left, but it's not equal to, so we're going to have an open circle. For the second one, we're at +2, it's greater than, so we're going to shade to the right with an open circle. For the third one, at 0, it is equal to, so we're going to do a closed circle and do less than, so we're going to shade to the left. And then the final one, we have greater than -7, but it's also equal to, so we're going to close circle and shade to the right. All right, now that we've kind of done the basics of an inequality, now we need to talk about actually solving an inequality. So there's a few special cases in these situations where if we multiply or divide by a negative number, you are going to switch the sign. So what does it mean by switch the sign? Well, if I have less than, then you switch it to greater than. If I have greater than, then you switch it to less than. If I have less than or equal to, then it becomes greater than or equal to. If I have greater than or equal to, then it becomes less than or equal to. So you are physically changing the direction of the sign if you multiply or divide by a negative. And that has to happen every time when you're solving an equation. So let's look at the example down here as a beginner. So we have -7x is less than 21. Now, if you were to solve this with an actual equation equal sign, we would do the dividing by -7. I'm dividing by a negative number here. So I had less than, but instead of less than, we're going to switch that sign to now make it greater than -3. Now, why do we need to do that? So let's check the range. So let's say that we left it as x is less than -3. So that means that it would include everything in below this range over here. So those are not true, but we're going to show you why. So I have let's pick a value. So I'm going to pick -5. And I'm going to plug -5 into my inequality. So -7 times -5 is less than 21. Well, -7 times -5 is 35, less than 21. That is not a true statement. So if we had left the inequality sign as it was, then we would actually not be finding the solution region. It's not true. So let's find one and let's plug it in that is in our solution region. Let's do 0. That's pretty simple. So I have -7 times 0 is less than 21. So -7 times 0 is 0. 0 is less than 21. That is a true statement. So that is the reason why we have to flip that sign when we multiply or divide by a negative value. So what we're going to do now is we're going to do several examples of solving an inequality and just checking them along the way. Alright, so for number 1, as we look at this, I have x plus 5 is greater than or equal to 13. We need to solve this and graph it. So if I were doing this as an equation, I would do my inverse operation and I would subtract 5. So x is greater than or equal to 8. So in this situation, I could graph my number line. You do not have to draw it necessarily to scale like I was doing earlier. Just make your general 0 and put 8 on the positive side. And we know that it is greater than or equal to. Okay, so greater or equal. So if it's greater than equal, that means that we're going to have a closed circle at 8, and it's greater than, so we're going to be shading towards the right side. Now, if you want to make sure that you got this right, all you have to do is pick a number. So a number greater than 8, or actually you could pick 8 itself because 8 is equal. So 8 plus 5 should be greater than or equal to 13. Well, 13 is equal to 13, so that's a true statement. So we did shade correctly. If you pick 9, you could say 9 plus 5 is greater than or equal to 13. Well, 14 is greater than or equal to 13, so that is a true statement. All right, so for the next problem, we have 2x minus 14. So we're going to start by adding 14, doing that inverse operation. So 2x, and I have 4 plus 14 is going to be 18. We're going to divide by 2. Now, we're not dividing by negative, so that sign is going to stay the same. Remember, you only flip it if it's a negative. And so x is greater than 9. So if it's greater than, we're going to shade to the right. But again, this is not equal to, so we're going to have an open circle at 9 and then shading to the right. And again, you can pick a value, check it, see if it works, and see if you shaded correctly. All right, so for number 3, if you think back to when we were doing equations, I asked you to compare a problem like this, and you can see that I have x divided by 2 minus 6. So that minus 6, we're going to add that 6 first because the whole problem is not being divided by 2. We will have an example in a second where the whole problem is being divided, just to refresh our memory. So when I add 6 to both sides, that's going to give me 13. And then I'm going to multiply by 2. So when I multiply by 2, I have x is less than or equal to 26. So on my number line, so again, this is why I wouldn't draw it to scale, because we don't want to draw 26 steps. But if I have a general scale, then you can make it fit correctly. So x is less than or equal to 26. So I'm going to do a closed circle at 26, and less than is going to be shading to the left. So anything that's less than 26 will be true for this statement. All right, so we're going to step these up just a little bit. And I have minus 3 for the first part of this problem. So I have -5 is greater than or equal to 10. Now, in this situation is where we're going to have to do some sign changes, because I'm going to wind up dividing by -5. So when I divide by -5, I need to switch my sign. So right now, I currently have greater than. I need to change it to less than. So when I divide by -5, I have x is going to be less than -2. So on my number line, I have 0, -2. Now it's less than. So we're going to have an open circle at -2 and shade to the left. So again, if I pick anything that's less than -2, so if I do -5, we'll say -3. plus 3 is greater than 13. Well, negative 5 times negative 3 is 15. 15 plus 3 is going to be 18. 18 is greater than 13. So this is a true statement. Okay, so that does work. All right, so back to what I was talking about just a second ago. This whole problem is being divided by 5, so we're going to multiply by 5 here. So I have negative x plus 2 is less than or equal to 50. So we're going to subtract 2. So negative x is less than positive 48. Now, in this particular situation, I have negative x, which is the same thing as a negative 1. So I'm going to wind up dividing by negative. So we're going to need to switch that sign. Instead of less than or equal to, we're going to make this greater than or equal to. So divide by negative 1. So I now have x is greater than or equal to negative 48. All right. So I have 0 here, I have negative 48, and it's greater than or equal to, and it is equal to, so we're going to do a closed circle and shade to the right. All right, for number 6, I'm going to start by adding 6. So I have 1/2 x is greater than 11. Now, when we talked about fractions before, we said it was much easier to multiply by the reciprocal. Remember, there's no such thing as dividing by a fraction. So the way to actually do that is you're going to multiply by the flipping of that fraction. So we're going to multiply by 2 over 1 because we have 1/2. So if we multiply by the reciprocal, my 2 and 1 cancels. So x is now greater than 22. So greater than, we're going to shade to the right. And we need an open circle because it's just greater than, it's not equal to. All right, and last 2 problems here. So one of the common mistakes I saw happening in some of our equation situations is several students here actually tried to add 17. Well, 17 in this problem is positive. Their subtraction that is behind it goes with the 3x. So instead of adding 17, we need to do the inverse, which is actually going to be subtract 17. All right, so if I have 41 minus 17, that is going to give me 24. Now, we are going to wind up dividing by that negative 3, so we're going to need to switch that sign. So when I divide by negative 3, I have x is going to be greater than, because it was less than, negative 8. So greater than, we're going to shade to the right, but it's going to be an open circle at negative 8. All right, and the last one. So we're going to add 4. So negative 5v is greater than negative 25. We are going to wind up dividing by that negative 5, so we're going to need to switch the sign. So instead of having greater than, this is now going to become less than. So v is going to be less than positive 5. So I have 0, I have positive 5, so less than means we're going to shade to the left, but we're going to have an open circle at 5. All right, so just to kind of summarize right quick, when we talk about inequalities, inequalities are like equations, but instead of an equal sign, you're comparing less than, greater than. When you're looking at shading, if it's less than, you're shading to the left. If it's greater than, you're going to be shading to the right. When you're solving an equation, when you divide or multiply by a negative number, you're going to make sure you flip that sign. And we got to make sure when we graph it on a number line that if it's equal to, we have a closed circle. If it's just greater than or less than, then we have an open circle.